Hello viewers, I'm Kausalya. Today we are going to solve problems in exercise 12.3. Problem number 6. In a circular table cover of radius 32 cm, a design is formed leaving an equilateral triangle ABC in the middle as shown in figure. Find the area of the design. So here we are having a circular table, right? So there is a circle whose radius is 32 centimeters and a design is formed leaving an equilateral triangle in the middle. So there is an equilateral triangle in the middle, right? Leaving this equilateral triangle, there are designs, right? So find the area of the design. Now we are going to find the areas which are covered by this design, right? So here the thing is, you see, so again the same diagram, but here I have included radius, right? So what do you mean by radius? A radius is nothing but it is a line which connects center to any point on the circumference of the circle, right? So this is a radius, this is a radius, and this is the radius. Everything is radius, right? So here you see from center to the circumference of the circle, it is known as radius, right? Therefore here the length of this line is 32 and again this is 32, right? And another concept regarding an equilateral triangle is all the angles are 60 degrees, right? Here it is 60, here it is 60, and again angle C is also 60. So here we are constructing a line OD, right? So again now we are going to consider the triangle OBD, right? So here in this case, you see, I need to find the area of this part. So here I am initially starting by finding the side of the equilateral triangle, right? Whenever the side of the triangle is calculated, automatically we can find the area of the triangle, right? So once you find the area, the next step is you have to find the area of the circle. So when you subtract area of the triangle from the area of the circle, then we can find the area of the design part. Can you understand? Yes. So here the first thing is we have to find this length of the side of the triangle. So here I am considering this triangle OBD. Right. So in triangle OBD, you see the entire angle is 60 degree, but here this part we are dividing this angle into two. So here the angle is 30 degrees, right? And I need to find BD. So what is the trigonometric ratio we have to use? We have to use cos theta, right? So cos 30 is nothing but adjacent side by hypotenuse. So here in this case adjacent side is BD and the hypotenuse is OB. Well, what is the hypotenuse side? The side which is opposite to 90 degree is known as hypotenuse. So here since this line is perpendicular to this line, this angle is 90 degree. Right. So cos 30 is equal to BD by OB. So again, what is the value of cos 30? It is root 3 by 2. And what is the value of OB? It is 32. So just substitute the value. And the value of BD is, I am moving this 32 to the left hand side. So here it is in the denominator. When it is moved to the right hand side, it becomes numerator. So root 3 by 2 into 32. Again 2 and 32 cancel. And here we are having 16. Therefore, the value of BD is 16 root 3. Right, but what we need actually, we need the total length. So from this diagram you see BC is nothing but it is 2 times of BD because D is the midpoint. So BC is 2 times of BD. So 2 times of what is BD? It is 16 root 3. Right. So 2 into 16 is 32. Therefore the value of BC is 32 root 3 centimeters. Right. Once we find the side of the equilateral triangle, we can easily find the area. Therefore, area of this triangle ABC is given by root 3 by 4 A square. A is nothing but side. Right. So what is the value of side? So here it is 32 root 3. So here just substitute the value 32 root 3 whole square. Right. So 32 square is written as 32 into 32 and root 3 the whole square becomes 3. So just multiply, and here we are getting the answer as 768 root 3 centimeter square. Right. Now we have calculated the area of the equilateral triangle. So once we find the area of the circle, then we can easily subtract. Right. So you see, area of the design is given by area of the circle minus area of the triangle. So area of the circle formula is pi r square, and area of the triangle we already got the value. Right. So pi r square. So what is the value of pi? It is 22 by 7, and the value of r is 32, because the radius of the circular table is given. So just substitute the values and solve, and finally we are ending up with this answer. Right, 22528 by 7 minus 768 root 3 meter square, because since this is area, the unit should be in meter square. Right, this problem is over. We will proceed with our next one. Problem number 7. In the figure, ABCD is a square of side 14 centimeters. So this is a square whose length is 14 centimeter. With centers A, B, C and D, 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. Okay, find the area of the shadowed region. So here this case, you see, we are having 4 circles, and each circle touches the 2 circles of the remaining 3 circles. That is, you see, consider this circle with center A. So this circle touches circle with center B and circle with center D, right, and C is separate. Similarly, when you consider this B, right, this B circle, so this B circle touches A circle and C circle. Similarly, C circle touches B circle and D circle, and again D circle touches A circle and C circle. Right, this is the thing which is given. So find the area of the shadowed region. So here in this problem, the diagram is clearly given. Right, so now we have to find this area of the shadowed region. Right, so here you see, this is your length of the, that is, this is the side of a square. This length is 14 centimeter. Right, so this length is 14 centimeter. Now when you look carefully, you see, that is from this point to this point, that is a line from the center to the circumference is known as radius. Right, therefore what about the radius of the circle? It is nothing but 14 divided by 2. So 14 by 2 gives the radius value, it is 7. Right, so once we know the radius of the circle, we can easily find the sector value. Right, so how to calculate the sector? First, where are the sectors present? You see, okay, this is one sector, this is one sector, this is one sector, and this is one sector. Totally here we have 4 sectors. Right, so first I am finding the area of a single sector. So here the formula is theta by 360 into pi r square. So what about the value of theta here? You see, because this is one sector and this is one sector, right? Here it is perfect L shape, therefore here the angle is 90 degrees. Right, so 90 by 360 into 22 by 7, the value of r is again 7. So 7 into 7. So when you cancel the terms, you see 90 and 360, they cancel by 4 times. And again 7 and 7 get cancelled. So the remaining terms are 22 into 7 by 4, which is 154 by 4. Right, so this is the area of a single sector. How many sectors do we have? So here we have 4 sectors, so just multiply the answer by 4. So area of 4 sectors is equal to 4 times of 154 by 4. So here this gives the answer as 154 centimeter square. Right, this is one way of calculating the area of the 4 sectors. Here the other thing is, as we solved in our previous problem, you see, 4 sectors, we have 4 sectors, right, 4 sectors. Even we can say it as quadrant also, right? Yeah, it's fine only. So you see, here we have 4 sectors like this. So when you arrange it properly, you see these four sectors, they together they form a circle. Say yes or no, because a circle has how many quadrants? It has four quadrants, or even you can say it has four sectors, right? This is one sector, this is one, and this is one, and this is one. So here we are, as we combine all the four sectors, they form a circle, right? So area of the circle is pi r square. What about the radius here? It is 7. So when you substitute the value, again you see here we are ending up with the same answer, 154 centimeter square. Right. So here why I had combined all these four sectors is, the main thing is they all have the same radius. Right. So since they have the same radius, automatically the area enclosed will be same. And that too, you see all the four sides, they have the same value, same length. Right. So here you can solve the value of area of sectors by any way. Right. When you solve by this method also, you are getting 154 centimeters square, and again when you solve by this also, you are getting the same answer. Right. So area of the shadowed region. So area of the shadowed region is nothing but, when you again look back at the problem, you see here we have to find the area of this shaded region. So here we have, this is a square, and we know area of these four sectors. So when you subtract the area of the sectors from the square, then we can automatically find the area of the shaded region, right? Therefore area of the square minus area of the four quadrants or four sectors. Okay, so here 14 into 14 minus 154. Okay, let it be sectors here, it will be fine. So 154, so which gives the answer as 42 centimeters square, right? So that's all for this video. If you have any doubt, let me know in the comment section. Thank you.